Hi everyone, my name is Hatem Nawar and I'm a customer engineer at Google Cloud. And today I'd like to talk a little bit about the economics of running pipelines on cloud. So let me start off by a quote. No one wants to spend more than they need to on their cloud investment. I don't know who said that, but someone must have everywhere. Let's all agree on that. But it's not easy, you see. There is that shift from the CapEx model to OpEx model, how grants are structured. Sometimes you're required to spend your grant money at a specific time or in a specific way or bill it in a specific way. The elasticity, which in the past 2 days we've heard how great it is to be able to suddenly spin up 1 million VMs on cloud, could be seen as a disadvantage because the finance department will say, wait, what? You can spin up 1 million VMs? How much is that going to cost? So it can be perceived also as a weakness of the cloud. And finally, how can you get all of these teams to work together, really, the finance, the IT, the management? But let's not take our eyes off the goal. What do we want to do here? So speed to results, this is an obvious one. I think we can all agree that if I'm going to run an analysis and wait for it to finish for weeks, then I'm really wasting my time. The time of researchers and people who know how to do this is very valuable. So speed to results is something, competitive advantage. Can I find out something that, or do something that others cannot? For example, a few years ago, I was working with a team at the University of York, and they were doing de novo gene assembly. They needed a massive machine to run one of the analysis, something that had over 1 terabyte of memory. But they didn't have any, so they went to cloud. But yeah, can I have a competitive analysis? Yes. Happier researchers? I say absolutely. I've seen many cases of people moving places because they're not happy with the tooling or the bureaucracy at a place. So how can I make sure that they have access to the tools they want at the time they want? So let's first agree on some concepts, understanding value versus cost. There is a cost to everything. There is a cost to building a on-prem cluster. There is a cost for electricity, a cost for staff to manage it, to run it, to replace disks that go bad. And there is value. But really, what I wanted to focus today is what is it that we care about? What's the unit? And I think most people here will agree that the unit is the analysis, sample, gene or protein or exome. So what I really want to focus on is what does it cost me to process one sample? And how can I optimize the cost of this one sample so I can optimize the spend per unit? Because it makes everything make more sense. A lot of questions I get sometimes when I start meeting with folks is about how can I calculate the cost of cloud? It's really unknown, but actually when we start shifting our spending this way, our thinking this way, it can make sense. And I'm going to come to this in a minute, but some guiding principles. Cloud cost for almost everything on cloud is equal to resources used multiplied by a rate. This could be a gigabyte per month. It could be a CPU hour, could be something. So I need 3 things in order to really be able to optimize and monitor my costs. I need visibility. I need to know what I'm spending my money on. Am I spending more on storage or compute or something? I need to optimize these resources. So am I using a VM that's too big? And then I need to do some sort of what we call pricing efficiency. Am I using the right type of agreement, commitment, preemptible, spot, and so on? So really the path to predictable cloud costs, which is, again, I see as an issue, is visibility. And also it comes all to accountability. I worked with lots of cloud teams in large research organizations. And one thing we found that when you give visibility to group leads, for example, and the lead researchers, you actually get accountability. There is no team lead that actually wants to spend $1 million by accident or want to spend too much money on a research. Everyone I've met are usually very reasonable, very accountable. They actually want to do the right thing. But in order to do the right thing, they need to know. So you have to surface this type of information to researchers. As a researcher, you want to know how much did you spend last month? How much are you spending? If you continue doing this, how much will you spend by the end of the month? So you can actually manage your budget and manage your finances. And then finally, you want some controls. And all of the clouds today, especially Google Cloud and everyone else, to be honest, is providing these types of budget alerts, quotas, dashboards, billing reports, and so on that you should take advantage of. The other thing I'd like to point out that there is a cost and time and effort to do every optimization, and you have to be selective. So some of the things are low effort, but high rewards. Like if you are not using spot and preemptible instances on cloud, switch to spot and preemptible today. See how much that saves you. It's just one line in the configuration, and that's it. There are other things that would take more effort, but could be worth it. All right. So some quick background about how Nextflow runs on Google Cloud, really. So you have a plugin for Google Cloud. This Google plugin interacts with either Batch API, which is actually quite new. It just went to GA today and was announced very recently, or the Life Sciences API, which we had for a few years. Nextflow tells Google Cloud what's how many CPUs you need, or how many, what's the VM type that you want, the disk size, which container to pull, and so on. And these APIs handle everything on cloud. The other option is you, of course, can run it on Kubernetes, but really, that's not what I'm here for today. What it looks like. So if you have, this is like a standard pipeline. You have one file, a sequence that you're going to do some processing, mark duplicates or whatever, and then you're going to split it into different intervals. You're going to process everyone separately, gather the information, do some further QC. The way that the API and Nextflow handle this is it launches a VM per process. So for every process that you have in your pipeline, a virtual machine is going to be launched. Once the process is done, it's going to be shut down. So this means if you are not running anything, the infrastructure that you have on cloud is virtually zero. You don't have anything on cloud. When you're running a pipeline, you exactly have the infrastructure that you need at the time you want it. So if I look at the process and how it looks like when it executes on cloud, and this is Google Cloud, but you can apply this to most other environments, cloud environments as well. So there is a staging environment. A staging is when I say, I need this VM, so I need to start a virtual machine. I need to mount the work directory, copy the scripts. I need to localize the input files. So if the input files are on a storage bucket or a cloud storage bucket, then I need to bring that. And then I run the process itself. I run whatever tool that I'm running, GATK, SAM tools, whatever. And then at the end, there is the unstaging, which is, did it run successfully? Were there any errors? Can I upload the logs? Do I need to put the output files somewhere else? Which is the unstaging phase. And it's very important to understand how this works, because it's a key to optimizing your workflows to run efficiently on cloud. So a famous example I always use is the Broad Institute. When they start moving to cloud, their GATK best practice pipeline used to cost $45, but after some processing, it went down to $5, and they now have on GitHub something called the $5 pipeline, and actually costs $3.85 last time I heard. So how did they do that? They started with moving their pipeline as is to cloud, and then they started doing some tricks. We're going to talk about them now. But really what I wanted to talk about, and the key message of today, is moving to cost per sample. I often get the question of how can I budget for my research? And some people think it's easier to budget for on-prem. I'm just going to buy this hardware, and they're wrong. You see, first you need to figure out how many machines and the specs of the machines that you need to buy. How are you going to buy them? Once you have them, you have to maintain them. You have lots of disks. Disks will go bad, believe me, I know. And you'll have to figure out how to replace them, teams, and so on. So it's not that actually easy. But if you move the cost per sample analysis, then what you need to figure out is, okay, I'll have some fixed infrastructure. Tower is going to sit on a JKE cluster. I'll have a SQL database. I'll have some fixed infrastructure, easy to calculate. And then I need to figure out, on average, how much does my sample cost, multiplied by the number of samples I want to process, and that's it. So actually moving to a cost per analysis improves the understanding of the cost of research in many ways. So tricks of the trade. And I've learned many of this, and I know some people are here that I learned this with, actually, how to optimize the cost of a sample, how to optimize the cost of a pipeline. And the very first thing is really VM right sizing. I see lots of pipelines out there that use the same size of the VM for all of the steps. And the steps could be very different. If you think about something, a tool like mark duplicates, notoriously single-threaded. It doesn't matter if you throw 4 cores, 2 cores, or 32 cores at it. It will finish in the same time. So maybe use a machine type that's actually faster, have higher clock speed, and less cores. A haplotype caller, very well threaded. It can use up to 32 cores. Why not go for it? And actually, Tower is an amazing tool to give you visibility. When you look at the reports in Tower, you can easily visualize what's the mean time, CPU usage, RAM usage, all of that. So VM right sizing. Task splitting versus grouping. So this was funny because it was mentioned in one of the sessions yesterday about how the process has one tool in most of NF Core, but sometimes it's good to combine processes. So I came across this when we were working on COVID variant surveillance. I think lots of the talks here had to deal with this, and viral samples are very slow. So if you're going to separate the process into different machines, you have the overhead of stopping a machine, starting a machine, downloading a container. So what we did in this case is we combined all of the tools in one container, optimized it, and then actually ran a small script in one process. And this did a huge, amazing improvement. Selecting best GPU for the job. Cheapest is not always the best. Sometimes to use a very powerful GPU that finishes in fraction of the time is better, and I've seen this with tools like Blast. Optimizing containers. So optimizing containers is key because every time you run your pipeline, you're going to end up downloading a container. So make sure that it's not bloated. Don't start from an Ubuntu container and then add more tools to it. Start from something smaller. It makes a huge difference. And it's about repeatability. If you're going to run 30 million samples, like the talk before me, then if you can save 5 seconds because the container is smaller, this is a huge cost saving. Using artifact registry, this is our container registry on Google Cloud. So make your containers closer and faster. Optimizing intervals is an interesting one. So I worked on SARIC with one of the researchers actually here, and part of this, one of the steps is it splits the sequence into intervals. The default intervals files that's on NF Core split them in so many intervals, many small intervals. But the overhead for each interval, because for each one you're going to download a container, process it separately, move files back and forth, was huge. So what we did is we replaced that interval file with one that simply split the gene into, I can't remember, 20 or 40 intervals. And suddenly we had a huge performance boost. Preemptible and Spot, again, Preemptible and Spot, for those who are not familiar with the cloud, are much cheaper instances. They're like our spare capacity. You get them for a huge discount, but they may be taken out from you at any time. But Nextflow can handle that, so you don't really have to worry. Software optimization is an obvious one. And finally, optimization is an iterative and ongoing process. So it's not something that you do at the beginning of your pipeline and then you forget about it. It's something that you keep on doing. You have to be mindful of how much it costs. Sometimes if an optimization costs a couple of days of researcher time but saves you then hours, then that's a good one to do. But sometimes it's simply, if you're doing some trials, sometimes it's not worth doing it. So next steps. If you have not used Google Cloud before, you can sign up for a free trial. If you are a researcher, you can also apply for a research grant, usually about $5,000. It can be more, depending on your application. Try the Google executors on Tower, and check out our latest announcement. We actually have our own Google Next event happening these days as well, and we have so many cool announcements happening. And that's it. Thank you.
Thanks for a great talk. I think this is a real question of a time. It's a great topic for this summit, where as more people are moving towards the cloud, people are thinking about costs and optimization much more. And we probably should have been doing it on traditional HPC for a lot longer, but now we really need to.
Yeah, actually, so many of these optimization comes just from the fact of how traditional HPC works versus cloud.
Just a couple of questions so that we don't run into the coffee break too far. Chris asks, are there any plans to have a recommendation engine for the VM types based on previous task executions or, I guess, requested resources?
That's a good one. So we do have a recommendation engine. The recommendation engines usually work for long-running VMs. So it's a good question. I don't think we have something that works on VMs that shut down and others start. But yes, something maybe I'll get back to the team and they'll figure it out.
And also one for me, your point about kind of these small running processes, I think it was mentioned by Robert yesterday as well, where the kind of start down, tear down time is significant in relation to the running time. I think that's a really interesting problem, and there's been talk about addressing that at the Nextflow level as well. So that's one to keep your eye on in the future. Great. Okay, thank you very much, Hatem.